activate. Just 4 more days and then your holiday. Just think about that. And sure, look, today is nearly over. Then just 3 more days.
Just 2 days.
Don't think about that. Maths.
I can't speak enough.
Chemistry exam was when? Thursday morning?
Yeah.
Before physics?
Yeah.
So when's maths?
After.
So, only 2 exams. Big deal. Big deal.
Big material. Physics material.
No. That's a little physics.
I will die.
You won't. Well, please, if you do, after the exam. Or if before, then that's 1 less exam to correct. Okay. Potential divider. Let's see. Did I get this down?
Do we have to solve all the questions, or is it like the math?
Yeah, it's like the maths. You have to do all of section A and 2 from section B.
We have a choice, 2 sections.
2 from 3, yeah. Now that's actually quite nice because what do you have to do in the maths exam in section B?
And we have to solve what?
Yeah, you see, so there's much more to do in the maths exam than in the physics. So you have to choose 2. Now, if you think about it, how many sections have we covered? 3. What are the 3 sections we've covered in physics? Mechanics? Yeah, so what do you think my 3 section B exam questions will be about? Have a guess.
Electric wave mechanics.
Perhaps mechanics, electricity, and materials.
So we study 2.
Well, unfortunately, in section A there are 12 questions, 4 from each section.
Section B. Section B is made of 3.
Choose 1. Choose 2.
Yeah, choose 2.
That's good.
I think so.
That's good.
I think so. Now you still have to do everything in section A.
Is it a lot of theory?
What do you mean?
Like definition?
I prefer, like the final exam, to mostly make them calculation questions. Now, of course, I have a couple of definition questions. You know,
Couple is
Is it a long one?
if I was to put marks on it, I would say maybe like 85% is calculation.
85, yeah.
And 15 is like, what is the definition of a whatever? It's not. What's it like in chemistry?
But chemistry definition is not as bad as physics.
Really? Like if I said to you, what is a Newton? Yeah, what?
Isn't that physics?
That's physics.
Yeah.
So what's a Newton?
Yeah,
Yeah, but what's
There's some that is difficult.
like what?
MCS.
That is not on the exam.
Okay.
What else is difficult? That was it, was it? Just that one?
There is other.
Go on, name one. Well then,
molecule?
I will not ask you that in the physics exam, don't worry. Anything else?
What kind of definition will we ask?
I like to ask fair definitions.
Is it the ones that are super long ones? No?
Is it the one with the formula?
Yeah, you can use the formula too.
Personally, the definitions I like to ask are usually like, what is blah blah's law, whatever it is, or what is blah blah's second law.
So you ask the thermodynamics law?
Could be thermodynamics, could be Kirchhoff, could be Newton. We did his 2 laws like this week or last week. Yeah, Kirchhoff. What?
Junction.
This is all recording, so you don't have to freak out. Anything else? And I also like to ask, like, you know, what is, say, Kirchhoff's junction law or whatever, and I might also ask something like a unit, you know, like what is the Newton, but all my unit questions I like to ask, you can get the definition very easily from using the formula. So like, what is the formula for force? MA. So 1 Newton we can say is 1 kilogram accelerated by 1 meter per second squared. You know, or the other definitions I like to ask the definitions where you can just use the formula. So like, for example, think about what is current. What's the formula for current, if you can remember? Q over T. So if you were to change that into a sentence, what would you say? You would say current is the rate of change of charge per unit time. You see, so these are the definitions I like. I like what is blah blah's law, and I like asking a unit definition where you can actually just use the formula to get the definition. I think that's quite reasonable.
What is like Newton's second law? Like there's the MA and there's the one from the...
I'll say which one if I was to ask that. Yeah, and if I didn't, then either is fine. Yeah. Okay, let's continue. Let's turn this back on. So, I think that's enough tips for the exam.
That's it.
Yeah, believe it or not, they were exam tips. Yeah. You missed them? Go. Come back.
We recorded, right?
Hey, well, this is recording. It's just getting this on the screen for you.
Listen to potential divider.
Okay, did you write this down, potential divider? Yeah? Did you write that down? Sorry, potential divider? Got that? Yeah. So, let's have a look. So, very, very simple lesson to finish the chapter and the semester. So, let's have a look at the circuit below. Not a very difficult circuit. What have we got here? We've got a power supply, and we can you see we can measure its voltage, and we call this voltage V in. And the reason we call it V in will become clear in a moment. Now, this circuit here has 2 resistors, but what's the difference between R1 and R2?
Variable.
This is variable and this is fixed. And here we have a V out. What I'm very interested in is a formula for calculating V out. So, what law could we use here to try and get the voltage? Huh? What law? Loop law. Yeah, whose law is that? Kirchhoff. So, by using Kirchhoff's loop law, he says that Vn minus IR1 minus IR2 equals 0. Yeah?
Yeah.
Now, I can rewrite that to get I. I think we're okay with that. You take the R's and the I's to the right, and then take out the I and divide by the R's. Now, remember I said I'm looking for V out. So what formula could I use to get the V out if I know the I? V equals IR. What R should I use though? R2. Yeah. So I get this formula. V out equals IR2, which is equal to R2 over R1 plus R2 times V in. In other words, V out equals, this is the result that I wanted for this lesson. This is the new formula for today. This is actually a special circuit, and as such you're kind of expected to know this formula for it, but even if you forgot it, it's actually in the formula book. So this is the formula for the output voltage in this circuit, and this circuit is called a potential divider circuit. Now, why do we care about this circuit? I'll show you in a moment, but first, can you write all of this down, please? Definitely draw this circuit, yeah. Because that is the definition of a potential divider. It is this type of circuit.
Who is the potential divider?
Who is it? Well, it's not a person. What do you mean who?
This R1 or R2.
Who? Huh? I'm confused. What are you asking me?
What?
Which one?
What?
What?
Which one?
Which one? What?
What? Which one is the potential?
R1, R2?
Yeah.
I'm confused. What are you asking me?
Which one is the potential divider?
No, the circuit.
Circle is.
Yes. Yeah. Okay, continue. Yeah. So,
Oh, it could be like some, have like a variable.
yes. It should. There should be some way to change the resistance. This is normal for a potential divider. Yeah. Okay, continue. So, precisely what is the potential divider? The potential divider allows for an input voltage to be reduced. Now, why am I saying reduced? Why not increase? Well, just before we go on, let's have a look here. Guys, look up, please. So, here is an input voltage. Can I change this? No, because it's fixed. Here is an output voltage. Can I change this? I can, because here's a formula for it. Now, which of these can I change in my formula?
R1.
R1. Now, what happens if I make R1 really big? What happens to this fraction?
Small.
It becomes smaller. And what happens if I make R1 0, the smallest? What would this become?
1.
Yeah, which would be what?
1.
If that's 0, you'd be left with R2 over R2, which is 1. So, in other words, what's the biggest we could get for V out? V in. That's the biggest. And if I start increasing this, it reduces. In other words, potential divider will take an input and make it smaller. It can't make it bigger. It can only make it smaller. So the potential divider it allows an input to be reduced. The output voltage can be found by this formula. Okay. Why might you want to reduce a voltage? Well, you know you have the formula P equals IB. What happens to the P if you reduce the voltage? The P will be smaller too. And if you think about the lights, you might have these at home on the wall, the dimmer switches. So you turn the switch and you can make the light brighter or darker. You know these dimmer switches on the wall? Yeah. So really, this is actually a potential divider. By turning the dial, what you're actually doing is changing the R2. So by making it dark, what you're doing is you're turning the dial to make the R2 bigger, and this will make the voltage get smaller and make the light less bright. Yeah. So potential divider this is where you would see it at home on a dimmer switch. Yeah. So they're quite simple to make. I think nowadays potential dividers are probably more complicated. This is a very simple one. Nowadays potential dividers would have lots of other parts to it, but the idea is still the same. You take the voltage and you try to reduce it. The disadvantage of this potential divider is you might waste power because by increasing the R1 you'll cause more heat here, maybe you don't really want to be doing. There are other ways to change the voltage which are more efficient. Okay, let's have a look now. We only have the one example, so let's do this one together. A circuit requires only 11 volts. However, the mains provides 220 volts, and you have two resistors. You have a 10 milliohm and an X milliohm resistor. So this is a bit like, this is the OR1, because you can change it, and this is the OR2. It's fixed. Draw the correct potential divider. Okay, we did that. Find the X. Alright, so we have to use the formula. So, what do we want for the output? 11, and the input? 220. Now, what do we have here for the resistor? So, what would this one here be? X. 10. 10. Yeah, 10 milli, and here X. Now, in fact, you might say, do I need to worry that it's milli? No, because this fraction here is what unit? No, actually, no units, because there's ohms on the top and ohms on the bottom. So in fact, we don't have to convert. We don't even care about the units. We can just put in 10, 10, and X. Now, of course, we care for the units here and here. So, can you solve that for me? You have 11 equals 10 over X plus 10 times 10. Give me the X. I guess I should have been clearer. I was hoping, or as an imagining, because I called one of them X, that one is going to be the variable one. Because this is what you would do in real life. You would say, I have this fixed resistor and I have this resistor I can change, so I'll call that X. What should I set this to so I can get an output of 11? Do you get the idea behind it?
But then shouldn't X be R2?
Did I say it the wrong way? Is X R1 or R2? X is R1. I hope that's what I said. I'm sorry if I didn't say that. Yeah. So that'll be 10 over X plus 10. You got an X? Anyone else?
Yeah.
You look so confused. What's wrong? R1 is what changes. That's the X.
I feel like it's 11 volts, then it's 11 volts for the R1 or R2?
R2. I look so unhappy. What's wrong? Tell me what you're thinking. I can help.
Why is the 11 volt not the R? Wait.
It is.
Which variable resistor is?
Here, let me draw it for you. So, you have here 220 volts. And then this is connected to something which can change, which we'll call it X milliohms. And then it's connected here to this one, which is 10 milliohms. And we would like to know what is the voltage here, which is called V out. So, using my formula, what did I need for V out? 11, was it? Yeah. 11 equals 10 over X plus 10 times 220. So, you can rearrange that. You can get 11x plus 110 equals 2,200. So 11x equals 2,090, yeah? So x is, what's that?
172.
172? Oh dear. 190? 190 milliohms. Okay. Oh no, sorry, over here. 190. Right, next part. Now, how much current is coming out of the divider? In other words, what's the current here? Right, what would be the easiest way to get that current? What formula? Yeah, I equals V over R, because we know the total voltage, what is it? 220, and the total resistance would be 200 milli. So is that 44 amps? No, what am I saying? 400? What's the current, please? I'm too tired to do this. 1100 amps. Is that okay? Yeah? Now, the last part and most important part. Why do we care about changing the voltage? Well, if we think about the example with the light, we want to change the voltage because we want less light. In other words, we don't actually have a voltmeter here. What would we have? We might have something like another resistor, like it could be a light. Now, this here, I say in the question, is 2 ohms. And I want to know what is the voltage here. Is it going to be my 11 volts? Will this be 11 volts? Yes or no? What do we think? Well, not quite, because this here, the resistance has changed. It's no longer 10 milliohms, it's now bigger, because now we have 2 resistors. We need to add these back together to one resistor. Yeah, so 1 over R equals 1 over 2 plus 1 over 0.01.
But didn't we change it so it was 11?
Exactly, and this you might think, in other words, I'm trying to show you a potential problem, that the moment you connect something to the potential divider, you'll change it. But look at how it changes. 1 over 2 plus 1 over 0.01, and then if I flip that, I get something which is, I think I must have typed that in wrong. Let's try it again. 1 over 2 plus 1 over 0.01, flip it. Oh yeah, sorry, it is the same, yeah. 9.95. The resistance has become 9.95 milliohms. Now, that's actually nearly the same as what it was to begin with. Originally, what did we say the R2 was? Originally, we said the R2 was 10 milliohms. Now, when we connect this guy, what's the R2 now? It's nearly 10 milliohms. In fact, if I recalculate it, what's that? 9.95 over 10 plus 9.95 times 220. Will I get 11? No, but I should get close to it. Oh, I must have mistyped. 10.9 was probably what I think I mistyped somewhere. 10.95 volts instead of 11. Now, why did that happen? Why did the voltage not change much? Now, it's good it didn't change, because I wanted it to be 11, and I nearly have 11, even when I connect the light. Why did it not change much? Why did the resistance stay roughly the same and the output voltage stay roughly the same? What was the reason in my circuit that made this happen? Well, it had something to do with the resistor, but not actually the variable one. Something to do with this resistor. Can anybody see? Huh? Yeah, it's because it's small. Because this value is so small compared to this, when you added the resistor together, this guy was not so important because he was quite big, whereas this guy was much more important because he was quite small, because in the end you have to flip it. So actually it's small numbers that make more of a difference. So this has not added to the total resistance much. As such, the voltage is still roughly 11 volts. So what's nice about the potential divider is if the resistance is small, once you set it, you can connect anything to it and you can get that voltage. Now you have to use, of course, small resistors, and usually they're very fine small resistors that are used. Like if you think about the light switch, it's only going to be a small resistor inside of it. Okay, is this okay?
What's the 10?
What's the 10?
Yeah, 10 plus 9.95.
Huh?
190 plus 9.97.
Yeah. 190.
109.
109. My handwriting's terrible. Alright. 9.95 milli over 10 milli plus 190. I'm sorry. So what did you get? Well, it's still close to... Is it 10.95?
10.947.
Ah, so 10.95 still. Yeah.
So
What's this?
Yeah, it's a... Leave them. They noticed my mistake and I fixed it.
No.
No, you're not a mistake.
What's the meaning?
What's
10 plus 9.
Oh yeah, this is the OR2 and the OR1 is 190.
R2
Yeah, we got it there. Yeah. Okay, question? Question, someone? Yes? No?
what was the question?
Did you have a question? That was my question.
No, what was the question?
Oh, he wants to know where did the 190 come from. I just reminded him that was what we got for the OR1.
No, the part B question.
Oh! The part D question was, a 2 ohm resistor is connected, what is the voltage across it? And the point I wanted you to see was it's still about 11 volts. It's actually just 10.95. So this is why the potential divider is useful, because you can set the voltage and connect something and it's fine. It stays roughly the same. Oh, you look so unhappy. What's wrong?
9.95 over 200.
The 9.95 was the new R2 I got when I connected the 2 ohm resistance to the 10.
Yeah. Then
And it huh?
you change the 10 to the 9.9.
Ah, flip it.
Yeah.
Sorry. Excuse my language. 9.95.
Yeah.
Sorry, so sorry. Ah, this is terrible. Disaster. Disaster zone.
Happy now.
I know, definitely not happy. Now let's see what my text message was now. Just check my phone. Okay. Continue.
Where's the 190 from again?
Dude, ask me that. It was the original R1, the X.
Oh, it was even? Oh, yeah.
It was the first thing we had to calculate. Yeah. Is it okay?
Wait, let me
Why is it take photos of you?
Yeah, I don't mean this picture now. Okay. Continue, guys. Question? Question? No? Is it okay? Yeah. The way they make the variable resistor is they have a long piece of wire, and then what you do is you slide a slider along the wire. So it's like you're changing the length of the resistor, and this changes the resistance. I don't know if you've ever seen this anywhere before, but in some places, like in some old buildings, instead of having a dimmer switch, what they used to have is something you would slide up or down on the wall. Have you ever seen that? But in fact, that's what the original dimmer switch looked like. It was something on the wall you would slide up and down. That would change the R1 and so change the voltage there. But now they're quite small and they can just be a switch. Okay, so yeah, that was it. There was just that one example. Perfect. Okay, so if you could just try that for just about 5 or 10 minutes.
If capacitor is parallel to each other, they flatter.
Yes, it's the opposite for capacitors, because you think they should be the same as resistors, but they actually add. Yeah? Can I close this?
Yeah.
Yeah.